So let us begin. So exclusively, see, what we are trying to do in these classes is to get you conceptually correct, and that too how to solve a mixed variety of problems, generally of the type one or more than one. Okay, and the approach should be such that 18 problems are generally asked per subject, that you know. For the past 6 years, basically, this has been the trend, 18 problems per subject. So for that, ultimately in mathematics, all of you know that 75 minutes you should devote for maths. This is the general trend, correct? Toppers are doing like that. 60 minutes for physics. This is for mathematics. This is for advanced, I'm telling you, right? This is for physics. And chemistry, generally 45 minutes. Maybe plus minus 5 minutes, it's okay, but not more than that, the deviation. Okay. So you have to devote at least 70 to 80 minutes for mathematics. Only then you will be able to do the justice. And you have to finish your chemistry within 40 to 50 minutes. Generally physics from 55 to 65 minutes. So plus minus 5 minutes you can take. Correct? तो इसको दिमाग में रख के आपको क्वेश्चन पेपर को अटेम्प्ट करना है. Correct? So now let us begin the problem. So get the value of this summation. Get the value of this summation. Okay, Ved Prakash, you tell me.
Sir, I tried to remove the 10 power 4 term from numerator, and then the other quadratic part, trying to divide it into two quadratic parts, which will divide n power 4 plus 4.
Which will divide n power 4 plus 4, yes. Okay, so basically what should be in your mind before you attempt this? See, this could either be a GP, first of all. Okay, so what are the different summation type of problems that JEE can ask? What are the different types? So one is obviously pure AP, pure GP, there is no problem. Other could be AGP. Next could be difference of difference in AP, like that. Then difference of difference in AP, the generalized version of that. Okay, in addition to that, this what could be the summation? When summation is extending to infinity, then that problem could be related to some integral also. Correct? So for that purpose, if it is directly convertible into r by n and 1 by n form, correct, function of r by n, then it is okay. And in very few problems, you might be able to estimate this between two integrals. But this does not seem to be like any of these. And last but not the least, this could also be of the type telescopic difference, if it can be expressed as Vn plus 1 minus Vn, or the difference of two terms. So in our mind, first of all, you should have a direction. And within 20 or 30 seconds, you will be able to know, okay, whether this direction is correct or not. So don't jump into directly solving this. Correct? So first of all, as all of you might have done, n power 4 plus 4, I want to write this separately. And what else? 3n square plus how much? 10n. 3n square plus 10n, and then plus 6. Like that. And this whole divided by. So first step, I believe, all of you must have done. Am I clear? Summation n from 2 to infinity. So this we are doing to just reduce the complexity of the summand. So if you divide this, you are going to get 1 upon 2 power n. So this is a pure GP. So this you can calculate. What will be the sum? What will be the sum? I think half. This sum will be half, right? Plus. Now the next term. Next term आप मुझे बताएंगे. How shall I express the next term so that it might be expressed as a telescopic sum? The summation. And the method of difference. So n power 4 plus 4, what are the factors? N power 4 plus 4.
N square plus 2n plus 2 and n square minus 2n plus 2.
Correct. So now I want to keep these two in the numerator in a manner that their linear combination could turn out to be the term 3n square plus 10n plus 6. तो +2 क्या करना चाहिए बताइए? 2n + 2, तो 6 लाना है, बोलिए what should I do? 4, I think I should keep 4 here. Sorry, and I should keep minus here. And this basic manipulation I think you can do on your own. So can you do this? This is sort of partial fraction, right? This is sort of partial fraction. So I think now you must be able to proceed. So this is going to be how much? 1 upon, tell me, 2 power n minus 2 into what? N into n minus 2 plus 2 minus 1 upon 2 power n into n plus 2 and then plus 2. So this is method of difference type 2. Please check whether I have written everything correctly and correct me if I am wrong. Is it all right? Yes. Tell me fast, Vacha. Is it all right?
Yes, sir.
Okay, so now this is what? This is basically Vn minus 2 minus Vn. So what all terms will remain? Obviously, when n is approaching to infinity, this is going to be 0. So what terms will remain? I think 2 in the beginning are going to remain, right? So n equal to 2 term will remain. So what is n equal to 2 term? So that will be half. And the next term, when I put n equal to 3, so that will remain. So that will be how much? 5 into 2, 10. Please check whether these two terms will remain and all others will get cancelled. Yeah, if I say this is Vn, then I must say this is Vn minus 2. Look here. So if I add from 2 to infinity, what is going to happen? V2 minus V0, like that. V3 minus V. V4 minus V. So all of you must have known this. And similarly, if I take up to m, this will be Vm minus 2, like that. So terms are going to cancel in this way. Yes, I think I have written Vn plus 2 I must write, no? 2. Yeah, this I have written. Actually, this is Vn minus Vn plus 2, not like that. So 2 V2 minus V4 shall come here. So cancellation will not be in this manner. Cancellation will not be in this manner. V2 minus V4, V3 minus V5, like that. And then V4 minus V6 and so on, plus 2. So see, these terms are getting cancelled like this. So all of these will vanish. 2 will remain here. But since m is approaching to infinity, they will go to 0. And the effective terms will be V2 plus V3. That is what we have written here. Just check the calculation whether it is correct or not. So I think the sum is going to be 11 by. So is it all right?
Yes.
Yes. Everybody understood, and we can proceed to the next one. So try this. All of you should be able to do this. And tell me the answer.
Sir, what is the equation?
It is x plus y plus z greater than equal to 150. Subari Praveen Kumar, please mute yourself. Subari Praveen Kumar. Yes, how much? 33C3?
Yes, sir.
Yes, so Gautam Reddy has got the answer. Yeah, please tell me. How do I proceed, beta?
So x equals to some 60 minus k1.
Yes. Okay. See, there are generally two approaches, I shall say, when we encounter inequalities of this type. First is the direct coefficient method. So when I say coefficient method, x, y, z are independent variables moving from 0 to 60. So basically this integral solution of this inequation will be the coefficient of x power r in, tell me, powers denote, exponents denote the values these variables are going to take, right? So x power 1, x power 2, x power 60. And same is the case for y, same is the case for z. So coefficient of x power r, and that too r can vary because coefficient of x power 150 is allowed, 151 is allowed, till what? So obviously what could be the maximum value of x plus y plus z? It could only be 180. So either you can do it like this, r varying from 150 to 180. But this does not, in this problem, this does not seem to be, what shall I say, quite satisfying approach, because what will happen? I have to apply the formula for this. So x power n minus 1 whole cube, and then denominator will be 1 minus x. Okay, I shall write 1 minus x, that will be easier to handle. So 1 minus x power 61, and then 1 minus x power minus 3. So you can do it in this fashion, and then you have to pick the coefficients of that and then apply the whole summation. But this is going to take time. And since we remember the formula, this is method. So generally, if the options are there in summation form, then you must go in this manner. This is also important because in one or more than one correct, what he might do, he can express the answer in different ways and present to you in terms of different options. Correct. So you must be prepared to handle all of them. And alternatively, as Gautam Reddy has told, that method number 2. So Gautam ne humse kaha, since x and y and z are moving from 0 to 60. So what is the transformation which will still make them remain in 0 to 60 is, tell me, x equal to 60 minus u. That is what Gautam has done, and most of you must have done, I believe. And z equal to 60 minus w. So this will be how much? 180 minus u minus v minus w greater than equal to 150. So u plus v plus w is smaller than 30. Correct. And what are the restrictions on u, v, w? So they will also belong to 0 to 60. But basically, strictly speaking, they are not moving till 60. U plus v plus w less than equal to 30. Correct? So now, how shall I proceed for that? So this, since this sum has to be smaller than equal to 30, so what shall I do? All of them are varying between this. So here we bring in another dummy variable. Correct? Because obviously they are allowed to take any values from 0 to 30. So we bring in another variable, u plus v plus w plus, let us say, k. Number of ways in which 30 or less coins, that two identical coins, can be distributed among 3 beggars, will be same as number of ways in which 30 coins can be distributed among 4 beggars. Because the coins which this 4th beggar is going to receive will ultimately decide the number u plus v plus w is going to be equal to. When k is 0, this is 30. When k is 1, this is 29, and so on. So I think the number of integral solutions, you must be aware, n plus r minus 1, c r minus 1. So you must have understood this. Is it all right for all of you? Yes. So shall we proceed to the next one? Number of integral solutions are 33, c3. See, first of all, so let us name them A, B, C. So we can follow here 2 methods in these type of questions. So first of all, let me take cos x as A, x plus 2 pi by 3 as B, and cos of x plus 4 pi by 3 as C. So A is cos x, B is, and they are at an angle of 2 pi by 3. Basically, what do they behave geometrically? They are the components of 3 vectors inclined at an angle of 2 pi by 3 with each other on a plane. And obviously their resultant is always 0. So ये आपको पता भी होगा कि a plus b plus c is always 0, even if they are sine or even if they are cos. So this you are aware, right? cos x plus 2 pi by 3 plus cos. You can apply the formula and check, or else you can say what I said just now, that they are the components of three vectors inclined at an angle of 2 pi by 3 with each other on it. Now, what should be your objective? To obviously reduce the complexity of this equation. So first of all, let us reduce the variable. So I shall replace c by minus a minus b over here. Nikhil, you are doing the same way? You did the same way or something different?
I replaced b equals to minus a minus and forming 50-degree equation.
Yeah, okay. Same thing, no? Like in place of c, you shall write minus a minus b. Same thing which I am doing, correct? So a plus b power 7. Now keep on checking the expression. So this will be a power 7 plus how much? A power 6. 21. I'm opening it binomially. 35. 35 then. A4. Not 35. It will be 21 only. No, 35 I wrote correctly. 35 A4 B cube. Then again 30. How much? A cube B4 plus 21 A square B5 plus 7 AB power 6 plus B power 7. Correct? Now, let us try to further simplify this. So I think I can take, I can cancel 7 basically first. So 3, 5. So can anybody tell me what is the final answer? How many solutions you are getting if you have solved? And then I want to take AB common. Please tell me what will be left. I think A power 5 symmetric expressions will be left. A power 5, B power 5. Next, if I take AB common, so this will be, yes, 3 A power 4B. Correct? Plus, again 3 AB power 4 and then 5. 5 how much? AB common.
A3B2.
Correct. A3B2 and then A2B. So this is equal to 0. Now further what I want to do with this also. So A power 5 plus B power 5 is also factorizable. And these two also, I think it is factorizable, and last two also it is factorizable. So I can take, I think, A plus B from all of these brackets outside. So A power 5 plus B power 5, if you divide by A plus B, what will be the quotient? Minus A cube B. Please correct me if I'm wrong. A square B square minus AB cube plus B power 4. This is the coefficient, sorry, quotient when you take A plus B common. And then here, what will be common? Here what will be common? 3AB into A cube plus B cube. And A plus B is out. So 3AB into A square minus AB plus B square. 3AB into A square minus AB plus B square. Please keep on checking at every step. And then I have taken 5A square B square. Is it all right? I'm going to write A plus B as minus C. Minus, obviously, I can divide. So what are the terms that are left now? Please tell me. First is A power 4. Next is B power 4. What else? A square B square. How many terms will remain? Plus 3A square B square. Correct? Please check. A square B square. And then A cube B. So plus
2A cube B.
2A cube B. And then I think symmetrical terms should come. No? Plus 2ab cube should also come. 2ab cube. Is it there? Yes, is it there? It is there. So I think everything we have written correctly over here. So this will be ABC times, if I make it a perfect square, a square plus b square whole square plus a square b square, not a square b square, ab I want to take common. If I take ab common, then what will be the term? 2a square plus 2b square plus ab. Can you check this? This is equal to 0. Is it all right?
Yes.
So basically, no, not AB in terms of this. I want to make it a perfect square. No. So what will be better? A square plus B square. What will be better? A square plus A4 B4. Because this will be 0. This is perfect square. You should take common in a way that this should never be 0. What should I take common? A cube. In place of this, AB is there. 2a cube. Because this is always positive. Ultimately, everything should turn out as positive. No?
A square plus AB whole square plus A square plus AB whole square plus A square B square.
That way I should think. So what did you say? Say it again.
A square plus AB whole square plus B square plus AB whole square plus AB whole square.
Correct. Because in this way, AB is turning out to be the value which the sign of which is not known. So rather than this, I should frame like A square plus AB. So if I write A square plus AB whole square, so that is going to be how much? A power 4 plus A square B square plus 2A cube B. Yes, I think this is better. B square plus AB whole square. So A square B square 2 times is there. And finally, A square B square. Is that what you were telling, right? Please check this. Is this all right? A power 4, B power 4. Then 2A cube B is also fine. Okay. And then 2AB cube is also there. And 3A square B is correct. So now see here, for this to be equal to 0, each of these expressions should be equal to 0. That means AB is 0, or A into A plus B is 0, or B into A plus B is 0. Basically, this I can write as A square C square also, because A plus B is minus C. So that you can look for the symmetry here. B square C square and A square B square. Finally, these are the factors A, B, C. Can you see this line? The last line. So these are the factors. Correct? And again, this could only be 0 if either A is 0 or B is 0 or C is 0. Correct? So how many solutions are there for this? So cos x will be 0. How many times in 0 to 2 pi? 2 times. And by rotation through 120 degree each. So 2 here, again 2 here, and again 2 here. So number of solutions are 6. Can you check this? Number of solutions via method number 1. Is it all right? Please check. Yes? Say yes or no. Number of solutions are 6. Yes. And alternatively, what we can do? Alternatively, this is one approach, which is pure algebraic approach, right? In which you are making use of the factorization. What else can come into your mind? The first student which I asked, I think, whom did I ask the question? Who told the cubic way? Okay. So now since a power 7 plus b power 7, you have to solve this. A power 7 plus b power 7 plus 6 c power 7. So let me define a power n plus b power n plus c power n. Let us say this I define as f of n or s of n. Let us say this is s of, correct? So you have to solve s of 7 equal to 0. A, B, C are the same thing. So since there are three variables involved, A, B, and C. Okay. So let me form a cubic whose roots are A, B, C. So for that purpose, I require the sum of the roots. So what is S1? S1 is perfect 0. What about S3? Not S3, ABC. So product of the roots, let me put this equal to K. And 2 at a time. Can you tell me what is going to be 2 at a time? If this is 0 and I'm going to square this. So A square plus B square plus C square plus 2 times AB, BC, C. What is going to be this? This must be equal to 0. And what is A square plus B square plus C square? Can you observe this? A square plus B square plus C square. Cos square. Yes, because cos square plus cos square plus cos square I can write as 2 cos 2 theta minus 1. So this will become 2 cos 2x minus 1. I will keep separate. Plus 2 cos double of that. That will be 2x plus 4 pi by 3. And then cos of 2x plus 8 pi by 3, which is effectively 2 pi by 3. Correct? So obviously this will vanish minus 1. So plus 3 plus twice summation AB equal to 3. So please keep on checking. I have obtained summation AB equal to 3 by 2. This is also 0, right? Cos 2x plus 4 pi by 3, 2 pi by 3. Their sum is also 0. Is it all right? See this approach and try to understand this approach. So here what we are going to form, what is the cubic? Tell me. So S1 is 0. What is the value of S2 that you have obtained? S2 is how much?
3 by 2.
Cos square, no, actually 1,
0.
not 3 by 2. I think the formula I have written cos square is not, cos square is what? 1 plus cos 2 theta, no? 1 plus cos 2 theta by 2. So basically cos square I should have written 1 plus, I shall multiply 2 cos square theta, first this by 2, okay, and this 4. So this is not 3 by 2. 2 cos square theta is 1 plus cos 2 theta, so this is going to be minus 3, and this is minus 3 by 4. Am I correct or not? Actually, I thought this was cos 2 theta, no? It was cos square theta. Is it clear? Please check. Summation AB is beta minus 3 by 4. Please answer me. Is it correct now? Yes? Say it.
The 2 should not be there, sir. Or 2 multiplied.
2 cos square 1 plus, yeah, but that will not make any difference. No? This is 0. Okay, now it is correct. No? Summation AB is minus 3 by 4.
Yes.
Right? Okay, so now S2, what is the value of S2 that you have obtained? Cos square plus cos square plus cos square. What is that?
Minus 3 by 2
No, not minus 3 by 2.
plus 3 by 2.
Correct. S2 is 3 by 2. Now form a cubic whose roots are ABC. So minus S1. S1 is 0 plus 2 at a time. So minus 3x by 4. And then minus What is the product? K. Please check. This is the cubic whose roots are A, B, C. If it is correct or not. So sum of the roots is 0, 2 at a time is -3/4 and product is K. ABC I have substituted equal to K. So now I shall proceed one by one till S7. So this is going to be like, what is the equation? So x cube is 3x/4 plus K. So x cube is how much? X cube is 3x/4 plus K. That means if you substitute A, B, and C and add it, so this is going to be x power n plus 3 multiplied by x power n, 3x power n plus 1 by x power n plus 1 by 4 plus K into x power n. In other words, S of n plus 3. Substitute A, B, C and add 3/4 S of n plus 1 plus K times S of n. Correct? Now let us start substituting the value of n. So if I substitute n equal to 0, then S3 equal to 3/4 S1 plus K into S of 0. Right? So what is S3? What is going to be S3 now? So this is going to be S1. S1 was 0 only. And what is S0? S0 is 3. Correct? Please check. So this is going to be 3K. All right?
Yes.
Okay. Similarly, what is going to be S4? From this equation only. So S4 will be 3/4. Tell me, put n equal to 1 plus KS1. S2 we have already obtained as 3/2. So this is going to be 9/8 plus KS1 and S1 is 0. So this is 9/8. Please check. S1 is 0. So S4 is a constant. S4 is a constant. 9/8. Right? What else? S5 is how much? S5 is 3/4. 3/4. S3. Put n equal to 2 plus KS2. So this is 9K/4. K times S2 plus 3K/2. That means it is a multiple of K that is more important. So 15K/4. Please check. 15K/4. This is S5. Next is S6. 3/4. 3/4. How much? S4 plus K times S3. K times S3. So what is S4? 9/8. So 9/8, 27/32 plus K times S3. So what is S3? 3K square. Please check it. Is it all right? S6. And then finally, what is going to be S7? S7. In fact, at S6, I don't think it is required. I could have directly write S7 because I only require S5 and S4. Correct. So no need to write S6 basically. Straight away from S5, you can jump to S7. So S7, let me write directly. So what is going to be S7? Tell me. What is going to be S7? And 2 and 3. In fact, evens are not required. No. In fact, S4 is also not required. You only require S2 and S3. So what you should have done, you can skip this S4 also. There is no requirement for S4. S5 you can directly write like this. No, S4 is also required. Okay. Why S4 is required? Because S7 it will contain that term. Correct. So S7 will be how much? 3/4 S5 plus K times S4 will also be required. So let us bring back those values also. What was the value of S4? If you remember, I just
9/8.
9/8. No issues. So I shall substitute here So S7, it will come out as a multiple of K. So what is going to be S7? Can you observe this? All of odd summations, sum of odd exponential summations, they are multiples of K. See S1 is 0 into K. S1 is 0 into K. Look S3 to the extreme left, it is 3 times K. Look at S5 at the bottom, it is 15 by 4K. And now S7, 3 by 4. So they are multiples of K, correct? So this you can observe into what? 15K by 4 plus 9K by 8. So some multiple of K only. And hence S of 7 equal to 0 implies that ABC is equal to 0, which we have already obtained in the previous approach also, that some of these odd powers will be 0 only when if A is 0 or B is 0 or C is 0. Is that clear? Is that clear?
Yes, sir.
See, there is also some geometrical implication of this. As someone said, he was trying with complex number. So basically Z1 plus Z2 plus Z3 is 0, right? If you look at it that way, if I take e power I x as your complex number Z1, and Z2 is how much? E power I x plus 2 pi by 3. So basically this is Z1 omega only, right? So what are the complex number involved here? Z1 omega and Z1 omega square. Is it correct? So what do we already know? That their sum is obviously 0. Z1 plus Z1 omega, 1 plus omega square is 0. And what is being asked in the problem? Can you tell me the real part of what? See, just a moment. Basically, the first term is cos power 7x. X plus 2 pi by 3. So when you are doing the odd power, what is the interpretation, geometrical interpretation of this result? That means the vector that you are taking, if you are taking the 7th power of that, then also the components of that vector along, let us say, two mutually perpendicular directions, that is cos and sine denote, right? With respect to unit magnitude, they will also vanish. Are you able to interpret this? See, what is this? What is the interpretation of this? Suppose there are 3 vectors. Suppose there are 3 vectors like this, like this. Yeah. So obviously there are some vanish in a plane. On a plane, there are some vanish. Even if you cube those vectors and so-called the corresponding complex number corresponding to that and take their components, then also it will vanish. Take power 5, then also it will vanish. Take power 7, that then also it will vanish. Is it clear? Getting the point?
Yes.
This is the geometrical interpretation. Because further onwards, what you can also ask that the value of S of 2m plus 1 for odd things. So this will be some multiple of K. So, or in other words, K divides this. So K will divide this. K divides S of 2m plus 1. कैसे करना है? What is the first step?
Ln 1 plus a sin x.
Actually, this is mod. So, okay. In terms of 1 plus a sin x you are getting, I don't think that will be a wise step.
Using King's rule and adding both of them.
Yeah, so first step should be to simplify this. So if we apply the 5th property, which we generally say that it is a king property. So I equal to, what is the first step? इतना लिखा भाई, कितना बनेगा? 1 minus 2 sin x. All right. So obviously king property is generally applied in a hope that it might simplify your integrand. तो कितना सम आ जाएगा अब इसका बताइए? 2i क्या हो जाएगा? 0 to 2 pi. इतना सबने किया ना फर्स्ट स्टेप? टेल मी. First step. What
Yes.
next? What next?
It is cos 3x by cos x, the inner one.
Okay, in terms of cos, you want to write this?
Yes.
0 to 2 pi. You want to write this in terms of cos. No. Cos 3x by cos x, you are telling.
Yes, sir.
Okay, you are converting this first into. You are converting this first into. See, Suvari Praveen Kumar. So many a times you are disturbing the class. Suvari Praveen Kumar. Praveen Kumar. Okay. So 4 cos square minus 1. And then 4 cos square, not minus 1, minus 3. Minus 3 into cos x by cos x. Okay. So this you want to write as cos 3x by cos x. Cos 3x by cos x. This whole mod. And this will be equal to what? 0 to 2 pi ln of cos 3x and then minus ln of cos x. What next? What next? This is 2i. Yes.
ln mod cos x is pi ln 8 by ln 2 by 8 for pi until pi by 2.
Okay, so this you have remembered the value. I can take 2 out and then further take 2 out. So 4 times 0 to pi by 2. And this ln of mod cos x, now I can remove the mod sign. And this value I think you remember as minus pi by 2 ln 2. Is
Yes.
that you are saying? So this will be 2 pi ln 2. Right? 2 pi ln 2. What about the first one?
Until 0 to pi by 6 as a period and replacing 3x with some t. We'll get similar form.
Yeah, 2 pi ln 2. First of all, I shall substitute 3x equal to t. 3x equal to t. So what will be that? Praveen Kumar, Suvari Praveen Kumar, you're disturbing the class. So 3x equal to, I shall write 3x equal to t. So this limit will vary from 0 to 6 pi. Ln of what? Ln of cosine of t mod, and dx will become how much? dt by 3. So value is 0. No? See, in fact, there is no need to write the value also. Can I take, this is multiple of this because period is 2 pi. Can I take 3 out? Because 6 pi is 3 into 2 pi. So this will be same as 0 to 2 pi this. So what is the value? These two are same. So they will cancel. So value is 0. Is that clear? Check everyone.
Yes.
What is the general term basically? Can you tell me? This is the product of 1 upon how much? 1 plus r minus 1 into iota whole square. 1 plus and r from 1 to n. Yes, this is your sum, right? Or in fact product p of n. Achha, p of n equal to this. See, there are many different things which are coming to your mind because this is the sum of squares. But you should be careful. This is not the squares of real numbers because second term is a complex number. Had this been the square of some real numbers, then we could have thought of converting this into complex number, sort of a square plus b square, and then taking their conjugate and multiplying, something like that. But that is not the case. So we should try rather to simplify this and look for further leads. 1 plus, so this is r minus 1 iota whole square, or plus 1 whole divided by 1 plus r minus 1 iota whole square. यही आएगा भाई. और product आएगा from 1 to n. Is that clear? So in the numerator, what will come? Tell me.
1 as
So,
minus I.
pardon me?
We can write 1 as minus I square.
You want to factorize this. So numerator 1. This is minus I square. And now I can make the factors. So if I make the factors, this will be 1 plus r iota into 1 plus r minus 2 iota, and this whole divided by. So I shall split this into product of two terms, and 1 plus r minus 1 iota. 1 plus r minus 1 iota, and this is the product r from 1 to n. R from 1 to n. All right. So now you can observe the product gets distributed over product of the terms. So I can write this is the product of this multiplied by, I will keep the product sign here also, into product of this r from 1 to n. So if I keep on multiplying this, what will remain in the first product? So this is what? If I put 1, so 1 plus iota upon 1 into 1 plus 2 iota upon 1 plus iota. Finally, 1 plus n iota upon. This is the first product. So these terms will get cancelled like this. So 1 plus ni will remain. And in the second product, what will remain? 1 minus I upon 1. Then 1 upon 1 plus I. Like that. Correct? Next word. 1 plus I upon 1 plus 2I. And finally, divided by 1 plus how much? N minus 1. So this time terms are cancelling like this. So 1 minus iota in the numerator and 1 plus n minus 1 iota in the denominator. So effectively, what remains? 1 plus n iota into 1 minus iota. So this is going to be how much? 1 plus n and then n minus 1 into iota whole divided by 1 plus n minus 1 into iota. And this is 10. So can I directly compare or what? I can also compare. No? There won't be any problem because this is a linear equation in n. So it will always have a unique solution. So comparing, I will get n equal to 9. You can directly compare when you observe that this is a linear equation in n. So is it all right? N is 9. Yes, please tell me.
Yes.
N is going to be equal to 9. Okay. We shall give you the next problem. Write this. So this can be directly proved using what? The combinatorial argument.
Yes.
So tell me, how will you go about proving this? Value equal to this? Finding the value?
Finding
I think
coefficient of x power 5. 1 plus x power.
you are doing this through method 1. Coefficient of x power 5 in 1 plus, this is what you are doing.
Yes.
And then minus 5c1 and what? 1 plus x power 404 like that. 5c2, 1 plus x power 303. So this is the summation of what? 202 and then 5c4 power 101. This is what? This is 5c0 also. So 1 plus, tell me, this is equal to what?
1 plus x
One-
power 1 minus
1 minus, yes, 1 plus x power 101 whole power 5. or I think the reverse way. No? This minus 1, I think. This minus 1. This power whole power 5. Right?
Yeah.
So power this minus 5c1 and so on. And last term, but last term is missing. That does not matter. That is going to be minus 1 only. Correct? Coefficient of x power 5 in this. So last term is going to be minus 1 only. So now tell me 5c4 and this. What about this term? What is the coefficient of x power 5 in this?
Expanding it.
What is the coefficient of x power 5? So 1 plus, through expansion, what will come? Because there will be many terms. How will you arrive at the coefficient of x power 5?
There will only be one term of x
Constant.
power 5.
1 plus x. In fact, not x. This one will get cancelled. No? So 1 not 1 c1x plus c2x square, like that. C4 and so on, power, and this whole power 5. Since x power 5 is there, so the first term will be the only expansion, because if you take x common, so x power 5 will be outside, and here this will be x square. So this is pure, what shall I say, algebraic approach, and coefficient of x power 5 will be 101 power 5. This is the answer, right?
Yes.
This is one way to approach this. Anything else that you can think of? Anything else that you can think of? 505C5, what does it denote? Are not you thinking in the direction of inclusion, exclusion? And let me put this in a bigger lot. Let me put this in a bigger lot. So what are they? And these are 101 quantities here, 101 quantities here. Correct? And let me name these blocks something like, this is block number 1, then block number 2, number 3. And so why this thing is coming into my mind? Because of the expressions here. 505. These are multiples of 101. 5C4 means choosing 4 out of them, choosing 3 out of them, choosing 2 out of them. Now tell me, what is your main objective? What is your main objective? Total how many objects you want to select? All are distinct objects. And total how many objects do you want to select? 5 objects. Now, can you frame the problem in a manner so as to obtain this expression? 5 objects. Tell me fast. So total ways to do this is how much? 505 C5. Tell me, beta.
Yes.
Not getting the point. See, and so in that, objects might come from set B1. It might also come from set B2. This is inclusion, exclusion, no? B3, B4, and B5. Is that clear? So total number of ways. This is equal to how much? This we already know as 505 C5. This will contain all possibilities of selecting this from this lot, total lot. So this is equal to this. And this is equal to how much? This is equal to how much? Tell me. Summation taken one at a
B1
time.
to son of B2.
Yeah, so I shall write this in this manner. S of 1 summation taken 1 at a time. Then all of the summation taken 2 at a time, like that.
Yes.
S4. Yeah. So you tell me. So if I go on like this, plus S5 also, let me write it that way. So S1 is sum taken 1 at a time. So sum taken 1 at a time, that means all the elements. So what is going to be in B1? And B, no, so B1 means when B1 is selected. So when B1 is selected, so what does it imply? What shall I write it here? BI means ith box is selected. Ith box is selected. So what is S1? Can you tell me?
5 times of 100, 101
5C1 into 101
C5.
C5 or C1? Tell me. C5. है ना? 101 C5 means all the 5 articles you are selecting from that lot. NB1 plus NB2 plus NB3 like that. Minus 2 at a time. That means you are selecting from 2. So what does it signify? Tell me. Minus 5C2. 5C2 all combinations. And then, so from 5C2, from those two. So from those two, what does it imply? That 202C5. See the expressions also. 5C1 into. So this is basically 5C4 is also same as 5C1. So this is the first expression. This is the second expression. 5C3 is also same as 5C2. What next? What is S3? Sum taken 3 at a time. So that is going to be 5C3. And when you club any 3, total number of entities will become how many? 303. See, you are getting this point or not? Basically what we are doing, हम क्या कर रहे हैं? Total 5 boxes हैं. I want to select 5 objects. So one way to do this is select any 5 out of 5, not 5. Now we are splitting it into 5 parts. इनमें क्या क्या हो सकता है? All objects could have come from box B1 or from B2 or from B3, B4, B5. So we are writing the general formula for the union of n events or n sets. So that is sum taken 1 at a time. So NB1 means all are included from B1. So like that we are proceeding. So next is what? Minus 5C4. Tell me. How much? 4 not 4. C 5. And finally S5 means from all 5 you have to select. That means you have to select all 5. And since 5 objects are to be selected from all of them, so you will pick how much? Tell me 1 from each. Is that clear or not? So that is going to be how much? 101 whole power 5. Is this clear to all or not? Because you are selecting 5, so that is okay. But when you are selecting all of them, intersection this, that means you are going to select 1 from each of them. Is that clear? So what is the value of this going to be equal to? That is 101 power 5. This you can transfer to the left side. Is that clear?
Yes.